Hi, this is Kirk Morales with Winning Variant. Today we're going to walk through a use case of using Winning Variant native app from the Snowflake marketplace to split test different model versions in your ML workflows. We're going to assume that you already have the Winning Variant native split testing app already installed. This is what it looks like on the marketplace. Once the app is installed and configured and running, we have access to the Winning Variant UI that we can use to view and manage experimentation assets. We'll come back to this in a minute after we talk through some of the asset generation. So this use case is going to walk through a scenario where we have a SaaS platform and we have a proprietary ML model that we use to predict churn based off of the behavior of a known customer. The idea here is that if we can predict a churn with some level of accuracy and then show that user, maybe it's a promotion or a consultation opportunity, something like that, that ultimately then we can reduce churn. In this example, the team's been developing a new version, we're calling that V2 of this model. It's been validated internally, we think it's more accurate, but what we want to do is before just releasing this to everyone, we want to run it behind a split test and ultimately make sure that it's actually having a measurable impact on churn and not negatively impacting other business metrics we care about before we do a full rollout. So that's the scenario we're going to walk through, and we're going to use Winning Variant to configure, implement, and then ultimately report on the results of that experiment to see how it's running in our environment. So the first thing we're going to do is create what we call a lab. A lab in Winning Variant is simply a workspace. This can be, every user can have their own. It could be one-to-one with teams, with different divisions. It doesn't really matter. In this example, we create what we call a samples lab. And you can see that to create an asset inside of the app, we're simply calling a stored procedure, and we're passing YAML that defines that asset. So in this case, we're saying create a lab. Here's the ID and the name of the lab, and Winning Variant will go ahead and create it. The other thing that's important to note here is as a result of the operation, we can see if it was created or updated. This lab was already created when we ran this, so it simply updated it. And Winning Variant internally will keep a running resource version. So every single creation or update event is tied to a particular resource version. This makes it really easy to roll back changes later if we need to. We don't have to remember exactly which properties of an asset were changed. We can just simply know that, resource version 2 or resource version 1 was maybe the most latest active version, and we can do an immediate rollback to that version. Now that we have a lab created, the next thing we need is a subject type. Subject type is a type of identifier that can go into an experiment, or you can think of it as the identifier that would be randomized as part of this experiment. So in our case, we want to detect churn per customer. So customer ID, a known customer ID, is going to be our subject type here. So we create this the same way we did the lab. We say we're going to create a subject type asset here. We're going to call it customer ID, and we are going to specify a type. In some of our SDKs, the type is merely just used as a way to validate an identifier before we use it. In this case, we're going to just say that our customer ID is a UUID, and we'll go ahead and create that. So now we have a lab, we have our subject type. That's all we need to create an experiment. So we're going to create that experiment. A few things about this. We want the experiment to be in that samples lab. We want to make sure we're using the customer ID. And then we're going to configure our version 1, which we're calling our control variant. That's the one that's currently live. And we're going to configure a version 2 variant, which we're going to call our treatment. That's the new version that we want to test. So looking at the YAML, very similar to when we created the lab and the subject type. We specify an experiment kind, we give it an ID, status, name, description, etc. We tell it we want it to live inside of that samples lab. We specify our customer ID subject type, a hypothesis, and we define those 2 variants. So we have our control variant, which is what we're assuming is our current version. And we have the treatment version, which is the model version 2 that we want to test. And we're launching this with just a single cohort. So we're saying cohort 1, we're going to use those 2 variants with a 50-50 split. Now, In practice, we would very likely launch our initial cohort with a much smaller percentage of traffic going to the new version so that we can make sure there's no catastrophic events or effects of launching this experiment. And once we feel good about it, we would introduce a new cohort where we would ramp it up to 50-50. In this case, we're just, for simplicity purposes, skipping the ramp up and we're going straight to that 50-50. And we can see our experiment is created here. So now we have the samples lab, we have our customer ID subject type, and we have the ML churn experiment that we're going to be using in our example here. I'm going to switch back over to the configuration UI inside of the Winning Variant native app. So this too is running completely inside of Snowflake. We can see we have our samples lab. Inside of this lab, we have a few different experiments. The second one here is our churn model V2. This is the experiment that we just created. And if I go into this experiment, we can see when it was created, the description, hypothesis, etc. We can also see the active variants and the splits of each. In a scenario where we have multiple cohorts, we'll be able to see all the historical, when they were introduced, what variants were in them at what splits, etc. So I'm going to switch back to our notebook. Now that all of our assets are created, the first thing I'm going to show is what the different dimension tables look like. So the first one is a very simple, just experiments table. All of these are exposed through the native app and available immediately. This one is showing high-level data on the experiment itself, including name, ID, the lab it lives inside of, the subject type, and what its active cohort is. If we had a winner, the winning variant would be identified here. But this particular experiment we haven't declared a winner yet, so there's no value there. Another table we expose is the experiment variance table. So this shows for each experiment all of the variants that may be used inside of them. So you'll see we have our control and our treatment with the description of each and the identifier that we use internally for each of those. Another table is experiment cohorts. So this is going to show for every experiment, it's going to list every cohort, and within each cohort, it's going to list all of the variants and their splits that existed for that cohort. So in our example, we have a single cohort with two variants. So we have two rows here, control, treatment, and we can see our 50-50 split. If we had done a ramp up, so let's say our cohort one was actually 95% control, 5% treatment, and then we ramped up to this 50-50 split, we'd then have 4 rows in this table, 2 for index 1, control and treatment, and then control and treatment again for cohort 2. All right, so we have all of our assets created. We're ready to go ahead and implement this experiment. What does that look like? Well, the first thing we need to do is figure out how we're going to manage assignments. So an assignment inside of Winning Variant is the variant that a identifier is assigned in an experiment. So you can think of, in our example, we're using customer ID as the subject type. So an assignment is going to be the particular variant that a specific customer is assigned to inside of this experiment. Specifically, is a particular customer meant to see version 1 of the model or version 2 of the model? Now, Winning Variant provides interfaces to get or create assignments for identifiers. And the app also maintains a persistent variant for that identifier inside of the experiment for the entire life of the experiment. So if I'm user 123 and I'm told that I'm meant to see or use model version 1, I'm going to use model version 1 every single time for as long as the experiment is active. The reason this is important is because we want to make sure that users have experiences where we have experiments that maybe actually impact the user experience, but also for consistency and to reduce contamination in the data when we're doing our analysis, it's important that these identifiers are persisted inside of the same variant for the entire experiment. So we have some pseudocode here that illustrates how we would maybe implement this in a Python script using a model from the Snowflake model registry. So we're pulling our model. We're going to call the winning variant user-defined function in this case to create or get an assignment for our customer ID inside of this ML churn experiment. This is going to return a variant, which in this case is going to be either control or treatment. And so then we just have a simple switch statement here where we say, if the variant is control, use version 1 of the model. And if the variant is treatment, use version 2 of the model. And because winning variant is going to keep track of the unique variants that a customer is meant to see, every time we run this for the entire life of the experiment, that customer will always be pinned to the exact same model version and will run into the appropriate branch of the code. Now, this is just showing an example using the UDF. All of this functionality is also available through a RESTful API. So if you visit docs.winninvariant.com, we have all the documentation that shows how you can pass a set of subject identifiers as well as a list of experiments, and Winning Variant will create or get any existing assignments for that subject inside of the particular experiments. And one of the nice things about the RESTful API is that you can do this with multiple identifiers and experiments all at the same time and have them all kind of returned in batch versus with the UDF, you're just getting a single identifier at a time. So that covers the implementation, very simple. So at this point, our experiment's running, we're generating assignments. At any point, we can query the experimentation.assignments table that's exposed to the native app. This is going to have a near real-time list of assignments that are generated as part of our experiment. Every assignment has a unique identifier. It has a subject type. In our case, the subject is the customer ID that we're randomizing on. We can see our experiment, the variant that ID is pinned to, the cohort during which they entered the experiment, and then the time that the assignment was made. So this is the time that they first entered the experiment. And all of this is managed and provided by the Winning Variant app. Now, we need to do analysis on this. We want to see if the experiment is actually working. Specifically, we want to know if version 2 of our model is reducing churn and not negatively impacting other business metrics we care about, such as lifetime value, average total monthly price, things like that. So what we did for the sake of this example is generate some sample customer data. And what we did here is we kind of simulated this view where we have a customer ID, which is our subject ID in the experiment. We have a plan that they're on, the number of months that they're active, days since they've last logged in, their current monthly price, and then that customer's total lifetime value. Now, for the sake of analysis, we're going to assume that churn is any customer that hasn't logged in within the past 30 days. So if it's been 30 or 31 days, we're going to count that customer as having churned. And remember, our goal here is to prove that with Model 2, we're actually reducing churn. So we want to see that rate go down. We're also then going to monitor the monthly price, average price, and lifetime value as what we call secondary metrics for this experiment to make sure that even if this new model version is working, that we're not negatively impacting other downstream metrics. So the first thing we can do just sort of as experiment validation is to do a cohort summary. In this particular case, we're looking at the number of assignments per cohort because we want to make sure that we have our 50-50 test, that nothing went wrong in the implementation or execution of this experiment to where we wouldn't have valid sample sizes. So we can see here that at the end of this, we have our 50-50 split, so we know that the assignments worked properly. We can look at this another way, and we can actually look at users that were assigned over time. So here we're looking at the same thing, number of assigned assignments per variant, but we're looking at it day over day. So we can actually look at this trend of assignments, and not only do they balance out to about 50-50, but this is also just a good visual way to identify any spikes or dips that may have happened where maybe something went wrong in the implementation and we noticed that there was a particular day where we had a larger number of users enter the treatment group versus the control group, for example. But in our case here, it's a pretty even distribution over time, which is great. So we've validated the cohorts. Our experimentation data looks pretty good. Let's go ahead and run some analysis. The first thing we're going to do here is create what we're calling a summary view for this experiment. So for each variant in our active cohort, which is just that first cohort, we want to see how many assignments there were. And we actually want to pull not just churn rate, but also some other stats for churn rate, specifically standard deviation and standard error, which we'll use later in our analysis. We can see in this case, again, pretty even distribution of assignments between control and treatment. And we can see that the churn rate in version 2 is actually slightly reduced compared to version 1, our control group, which is great. In this notebook, we're running some additional stats in Python against that initial data. Specifically, we're pulling our t-stat and p-value and adding them to the table. So here we're going to have a very similar table, but we're going to add our p-value, which we can use ultimately to determine if we've reached statistical significance on this test. And in this particular case, we're at 0.13, probably a little too high to call this test at this point in time. We'd want to see more data come through before we actually declare a winner or loser one way or another. Now, that tells us how this experiment is performing relative to churn. But if you remember, we also wanted to make sure that we weren't hurting any other downstream metrics. So we have another example query here, which is going to be evaluating lifetime value average and lift, and then also looking at the change in average monthly price per assigned group, just to make sure that there's not any major discrepancies that we need to consider. In this data set, we're seeing something that's actually really interesting. So if you remember from above, we were showing that churn was slightly better in our treatment group, which is what we hypothesized would happen. However, when we look at our secondary metrics, we're seeing that our monthly average price is actually lower for our treatment group. So it's about 2% lower. And our lifetime value is actually about 2.5% lower as well. Now, based off of our p-value we saw above, it's way too early to call this test anyway. However, these are the sorts of things that we'll want to monitor through the life of this experiment to make sure that even if churn is being reduced, that we're not hurting other metrics downstream. And we could very well get to a point in this type of experiment where we say, hey, churn is better, but it's our LTV is actually lower. So we need to go back and reevaluate that version 2 of the model before we consider a wider deployment, because we don't want to hurt some of our other fundamental metrics. So these are just examples of the type of analyses that you might be able to do with winning variant. The benefit of having your experimentation data right next to your business metrics inside of Snowflake is being able to write these joins directly on both data sets without having to build complicated pipelines to bring experimentation data in or exfiltrate your sensitive business metrics out to some other platform. Everything here stays inside of Snowflake and can be joined on, instantly with your own queries, either in SQL or in Python, as we showed in this example. One of the things that we help customers with as part of their onboarding is building out these custom analytics pipelines. We understand that every business has nuances. They have different sets of metrics that they care about, and depending on what team a product manager might be on, or what other downstream metrics they influence, pipelines might be slightly different for different experiments. So we work with customers to develop their custom analytics pipeline based off of winning variant data so that analysts have exactly the data that they need to make informed decisions. Thanks for taking the time to watch this walkthrough. If you have any other questions, please reach out to us. You could visit us at winningvariant.com. We also have some additional documentation and walkthroughs at docs.winningvariant.com. Thank you.